So hey guys, welcome to my channel. I am Santosh and here in my channel I discuss topics from physics and mathematics. As usual, today I am here with one more new video for you guys, and in this video I am going to discuss some important questions related to properties of charges. Guys, before starting the discussion, I request you guys to watch my previous video on properties of charges, and link for that video is given in the description below, or else you can click on the I button to watch that video. So guys, without wasting much of our time, let's get started. Guys, let us begin our discussion with question number 1. Three identical metal spheres A, B and C having charges plus 20 coulomb, minus 30 coulomb and plus 70 coulomb are brought in contact with each other. What will be the charge on each sphere when they are separated from each other? Option number 1, minus 20 coulomb, plus 20 coulomb and plus 20 coulomb. Option number 2, plus 10 coulomb, plus 30 coulomb and plus 40 coulomb. Option number 3, plus 20 coulomb, plus 20 coulomb and plus 20 coulomb. And option number 4, plus 20 coulomb, plus 40 coulomb and minus 30 coulomb. Guys, I will give you 3 seconds. Please pause the video and write your answers down in the comment section. Let's see who gets it right. Guys, here in this question we have 3 identical charged metal spheres carrying charges plus 20 coulomb, minus 30 coulomb and plus 70 coulomb. And these charged metal spheres are brought in contact with each other and then they are separated. We need to tell what will be the charge on each sphere when they are separated. Guys, to answer this question, you need to know what happens when you bring 2 identical spheres carrying unequal amount of charges. Guys, when you bring 2 identical spheres carrying unequal amount of charges, the one which has more charge will give it to the one which has less charge, and at the end when you separate them, both of these spheres will have equal amount of charge. Now in this case we have 3 identical charged metal spheres carrying unequal amount of charges, and when you bring them in contact with each other, they exchange charges, and at the end when you separate them, each of these spheres will carry equal amount of charges. Now we need to know what is the total charge carried by these 3 metal spheres. Guys, total charge on these spheres is given by sum of charges on each sphere. That comes from the property of charge, which is scalar nature. Charge is scalar in nature, and total charge on 3 spheres is given by algebraic sum of charges on each sphere. So total we have plus 20 coulomb, minus 30 coulomb and plus 70 coulomb. We have total of plus 60 coulomb here. And when you bring them in contact with each other, this 60 coulomb will distribute among these 3 spheres equally, and at the end when you separate them, each of these spheres will have plus 20 coulomb, plus 20 coulomb and plus 20 coulomb. So answer to this question is option number 3, which is plus 20 coulomb, plus 20 coulomb and plus 20 coulomb. Guys, now let us move to question number 2. What will be the nature and magnitude of charge on conductor if 10 raised to 20 excess electrons are added to it? Option number 1, minus 20 coulomb. Option number 2, plus 10 coulomb. Option number 3, plus 16 coulomb. And option number 4, minus 16 coulomb. Guys, again I will give you 3 seconds. Pause the video and write down your answers in the comment section. Guys, here in this question we have a neutral conductor, and to that conductor 10 raised to 20 excess electrons are added, and we need to find the net charge on this conductor. Guys, neutral body is the body which has equal number of electrons and protons, and to turn this neutral body into a charged body, we need to make the number of protons and electrons unequal. How do we do that? It can be done by adding some extra electrons or proton to that body, or it can also be done by removing some electrons or protons from that body. But we have one problem here. Protons are very heavy compared to the electrons, and they are held in the nucleus by a strong nuclear force. So moving protons in and out of the body is not possible. On the other hand, electrons are lightweight and they are relatively free. We can move the electrons in and out of the body to make that body charged. So here basically we have 2 options. One, add extra electrons to the body, or remove some electrons from that body. Let us see each case. Guys, first let us see what will happen when we remove some electrons from the neutral body. Guys, if you remove some electrons from the neutral body, then that body will have more number of protons compared to the electrons. Let's say if you remove n electrons from that body, it will have n extra protons compared to the electrons. So net charge on that body will be equal to n into E. Here n is the number of protons which are more in number, and E is the basic unit of charge, which is equal to 1.6 into 10 raised to minus 19 coulomb. So net charge on the body will be positive when we remove some electrons from that body. And similarly, when we add extra electrons to the body, the net charge on the body will be negative, because charge on electron is negative. And the total charge Q will be equal to minus Ne in that case. So here the body will have n extra electrons compared to the protons. So charge on that body will be equal to minus n into E. Again, E here is the basic unit of charge, which is equal to 1.6 into 10 raised to minus 19 coulomb. Now in general, we can write charge on any body as plus or minus Ne based on whether it has more number of electrons or protons. So this property of charge is known as quantization of charge, according to which the charge on any body is integral multiple of basic unit of charge. So charge on any body is always integral multiple of basic unit of charge. Now coming back to the question, here they have added 10 raised to 20 excess electrons to the neutral conductor. So net charge on the body will be negative, and that charge is given as minus Ne. Here n is 10 raised to 20 and E here is 1.6 into 10 raised to minus 19 coulomb. If you multiply these two values, you will get net charge Q on the body as minus 16 coulomb. So answer to this question is option number 4, that is minus 16 coulomb. Guys, now let us move to question number 3. Two identical metallic spheres A and B of exactly equal masses are given equal positive and negative charges respectively. Then option number 1, mass of A is greater than mass of B. Option number 2, mass of A is equal to mass of B. Option number 3, mass of A is less than mass of B. And option number 4, none of the above. Guys, again pause the video and write down your answer in the comment section before looking at the answer. Guys, here in this question we have two identical metallic spheres A and B having equal masses. Let's say mass of A is equal to mass of B is equal to some m. And these two spheres are given equal amount of positive and negative charges. So let's say charge on sphere A is plus Q and charge on sphere B is minus Q. Now we need to tell what happens to the masses of these spheres after charging. Guys, in the previous question we discussed that to turn a neutral body into a positively charged body, we need to remove some electrons from it. Similarly, to turn a neutral body into a negatively charged body, we need to add some extra electrons to it. Now here in this question also, to turn the sphere A into a positively charged sphere carrying charge plus Q, we need to remove some electrons from it. Similarly, to turn sphere B into negatively charged spheres carrying a charge minus Q, we need to add some extra electrons to it. Since the magnitude of the charge on each sphere is same, so number of electrons that are removed from sphere A should be equal to number of electrons that are added to the sphere B. Now after charging, if you look at the masses of these spheres, mass of sphere A is equal to m minus n into me. Here m is the initial mass and n is the number of electrons that are removed and me is the mass of electron. Similarly, the mass of B is equal to m plus n into mass of electron. Here m is its initial mass and n is the number of electrons that are added and me is again mass of electron. Now from this you can clearly see that mass of a sphere A after charging is less than mass of sphere B after charging. So answer to this question is option number 3, that is mass of A is less than mass of B. Guys, next let us move to question number 4. If body is charged by rubbing it with other body, its mass, option number 1, increases, option number 2, decreases, option number 3, may increase or decrease, option number 4, remains the same. Guys, before looking at the answer, again pause the video and write down your answer in the comment section below. Guys, if you take two objects and rub them against each other, both of these objects will get charged. And this method of charging is known as charging by friction. Guys, the reason why this happens is that some materials by their nature always wants to lose the electrons, and on the other hand some materials always wants to gain the electrons. And the material which loses the electrons will become positively charged, and the material which gains those electrons will become negatively charged. Guys, in fact, we have a list of materials known as triboelectric series, in which each material is ranked based upon its ability to give or take electrons. Now here we have a triboelectric series, and in this list the materials which are ranked higher are the materials which always wants to lose the electrons, and the materials which are ranked lower are the materials which always wants to gain the electrons. Now here in this list, if you choose two materials which are sufficiently far away from each other, you can charge them by rubbing against each other. For example, here I have taken a silk cloth and a plastic marker. Now here in this list, silk cloth is ranked higher compared to the plastic, and when I rub these two against each other, silk cloth will lose some electrons and becomes positively charged, and marker will gain those electrons and becomes negatively charged. Now in the question what they are asking is, what happens to the masses of these objects after charging? Now after charging it has lost some electrons, so its mass will reduce, and after charging it has gained some electrons, its mass will increase. Now answer to this question is option number 3, that is mass of object may increase or decrease based upon whether it has lost electrons or gained electrons. Guys, next let us move to question number 5. Mark out the correct option. Option number 1, the total charge of the universe is constant. Option number 2, the total positive charge of the universe is constant. Option number 3, the total negative charge of the universe is constant. And option number 4, the total number of charged particles in the universe is constant. Guys, again pause the video and write down your answer in the comment section below. Guys, to answer this question, let us consider the whole universe as an isolated system, and let this be the state of the universe at time t. Here Q1 is the total amount of positive charge that is there in the universe at time t, and Q2 is the total amount of negative charge that is there in the universe at time t, and N1 is the total number of positively charged particles in the universe at time t, and N2 is the total number of negatively charged particles in the universe at time t, and M here is the total number of uncharged particles in the universe at time t. Now from this state of the universe, you can say that total amount of charge at time t is, that is Q1 plus Q2, that is total amount of positive charge plus total amount of negative charge. Now what I will do, I will take one uncharged particle. I will take one uncharged particle and remove some electrons from it. Let's say I remove 10 electrons from it. Now what happened is, I have created a positively charged particle with charge 10e, and I have 10 extra electrons. Now let us see what has changed in the universe. Now after some time delta t, the state of the universe is like this. Now Q1 plus 10e is the total amount of positive charge that is there in the universe. Why 10e? Because we have created an extra positive charge of 10e, magnitude 10e. Now Q2 minus 10e is the total amount of negative charge that is there in the universe, and N1 plus 1 is the total number of positively charged particle in the universe. Initially it was N1, now we have created one more, so it is N1 plus 1, and N2 plus 10 is the total number of negatively charged particles in the universe, and M minus 1 is the total number of uncharged particle in the universe. Initially it was M, now that one particle has been converted into charged particle, so now total number of uncharged particle in the universe is M minus 1. Now what you have seen here is, the total amount of positive charge in the universe is not constant, it can be changed. Now again, total amount of negative charge in the universe is also not constant, it can also be changed. The total number of charged particle in the universe can also be changed. So these three are not constant. Now if you look at the total amount of charge in the universe after some time delta t, here total amount of charge is Q1 plus 10e plus Q2 minus 10e. So total amount of positive charge is Q1 plus 10e, and total amount of negative charge is Q2 minus 10e. So it will become again Q1 plus Q2. Now after all these change, what has remained constant is the total amount of the charge. Total amount of charge. So only thing that remains constant over time in the universe is total amount of charge in the universe. So total amount of the charge in the universe is constant, And answer to this question is option number 1, that is in universe total amount of charge is constant. Guys, now let us move to final question of this video, that is question number 6. Here we have three statements. A. Charge cannot exist without mass. B. Charge is invariant but mass is variant with velocity. C. Charge is conserved but mass alone may not be conserved. Option number 1, A, B and C are true. Option number 2, only A and B are true. Option number 3, A, B are false, only C is true. Option number 4, A, B and C all are false. Guys, again first pause the video and write your answers down in the comment section before watching the answer. Guys, now let us look at these statements one by one and try to find out answer to this question. The first statement is charge cannot exist without mass. Charge cannot exist without mass. Guys, this statement is true. Why? All the charge in the universe is due to two fundamental particles. They are electrons and protons. All the charge in the universe is due to these two particles. And these two particles have masses. Mass of proton is 1.672 into 10 raised to minus 27 kg. And mass of electron is 9.1 into 10 raised to minus 31 kg. So this statement is true. You cannot separate charge from the mass. But on the other hand, mass can exist without charge. Mass can exist independently without charge. Why? The reason is we have one more fundamental particle, that is neutron, which has mass but no charge. Neutron has mass but no charge. So first statement is true. Guys, now let us move to the next statement. Charge is invariant but mass is variant with velocity. Charge is invariant but mass is variant with velocity. What does this mean? Guys, the amount of charge on any object does not depend upon its velocity. Basically, the charge is independent of motion of an object. On the other hand, mass depends upon the velocity of the object. Mass depends upon the velocity of the object. Now, from our earlier classes, we know that mass is actually defined as the amount of matter that is present inside the object. Mass is defined as amount of matter that is present inside the object. Now, when I say mass increases or mass changes with velocity, does that mean the matter inside the object also changes? Does that mean the matter inside that object changes when it starts moving? The answer is no. Now, to understand how mass changes with velocity, you need to know another definition of mass given by Einstein. Guys, Einstein said mass and energy are the same things. Mass and energy are the same things. In fact, mass of an object is basically defined as the amount of energy that is present in that object when it is at rest. Mass is basically the amount of energy present inside that object when it is at rest. And we call that as rest mass, and let us denote that by m0. Now, when the same object starts moving with, let's say, with velocity v, it will have more energy, right? It will have additional kinetic energy. Now, energy of that object is more compared to when it was at rest. In other words, I can say that mass of the object is more when it is moving compared to its mass when it is at rest. So, mass of an object moving with velocity v is given by m0 divided by under root 1 minus v square divided by c square. Here, m0 is the rest mass or energy that is present inside the object when it is at rest, divided by 1 minus v square divided by c square. Here v is the velocity of that object and c is the velocity of the light in vacuum. It is the speed of light in vacuum. Guys, we can say that mass depends upon velocity if you use this definition given by Einstein, where mass and energy are equivalent. So the statement that is charge is invariant but mass is variant with velocity is actually true. Guys, now let us move to the last statement. Charge is conserved but mass alone may not be conserved. Charge is conserved but mass alone may not be conserved. Guys, while discussing the previous question, we have seen that total charge in the universe remains constant with time. Total charge in the universe remains constant with time. And this property of charge is known as conservation property, or in other words, we can say that charge is conserved. But when it comes to mass, mass alone may not be conserved in some situations. Because usually when we take example of normal chemical reactions, mass in this case will be conserved. That is, total mass of reactants is equal to total mass of products in normal chemical reactions. But this is not true when we look into the nuclear reactions. For example, here I have a nuclear reaction where we have 8 protons and 8 neutrons combining to form a 1 oxygen nucleus. 8 protons and 8 neutrons combining to form 1 oxygen nucleus. Here the mass of reactants, that is 8 protons and 8 neutrons, is not equal to mass of the oxygen nucleus. In fact, it is less than the mass of combined mass of 8 protons and 8 neutrons. Mass of oxygen nucleus is less than the combined mass of 8 protons and 8 neutrons. Now this difference between mass of products and reactants is known as mass defect. And Einstein said that mass and energy are same things. So this difference in mass is actually converted into energy while the formation of oxygen nucleus was taking place. And the amount of energy that is released during this process is given by this famous equation, E is equal to delta mc square. Here delta m is the mass defect or the difference in the mass, and c is the speed of light in the vacuum. So basically when we are talking about nuclear reactions, we say that mass energy is conserved during the reaction. We don't say that mass alone is conserved during the reaction. So this statement is also true, and answer to this question is option number 1, that is A, B and C all are true. Guys, with this we come to the end of this video. If you like the video, please hit the like button and also share this video with your friends. And finally, don't forget to subscribe to my channel and click on the bell icon so that you will always be notified whenever I drop a new video. So guys, thanks for watching and stay tuned for the next video.